So these are the another questions of matter around us, class 9th, chapter 1. Show experimentally that matter is made up of small particles. How we can show? Take a 100 ml beaker and fill it with 50 ml water. Mark the level of the water in the beaker. So by taking a 100 ml of beaker, we are taking only 50 ml of water. Add 1 tablespoon of salt to it. Only 1 tablespoon of salt. Stir the water until the salt crystals can no longer be seen and are completely dissolved. Now the level of water. Note the level of water. So completely dissolve the salt in the water and note down the level. How much level? The level of water does not increase. And after dissolving the salt, the level doesn't increase. See here. They have dissolved salt in the water and after dissolving it, the level is same in all the three the beakers. Why? The level of water does not increase after the addition of salt. This observation supports the assumption that matter is made up of particles. As a tablespoon of salt contains many salt crystals which are made up of salt particles, these particles were able to dissociate in water and gets evenly distributed in the intermolecular spaces present in water, due to which the level of water did not change. See, if we take something like in this beaker, if we add a stone, which are solids, they are bigger stone, they won't get dissolved in the, because they are of larger pieces and compactly arranged, they can't dissolve in water. Okay, this water will get filled up, or this beaker will be filled, and there is no changes, no dissolution. The rocks will doesn't dissolve. But when we take a tiny particles like salt, now salt can dissolve in water, and here it dissolved in water because the spaces present between the particles of the water can be occupied by the small particles. The spaces can be occupied by the small particles of the salt, and thus they dissolve there in the water uniformly all over the water, not only in a certain amount of water, all over the water in a uniform way, and thus the level of the water does not increase. Let's see. Next, describe by experiment the relationship between the rate of diffusion and density of the liquid. Rate of diffusion and density of liquid. Now, diffusion is the movement of particles from one place to the another, and density is the amount of particles present in a unit volume in a particular area. Okay. Experiment. In a glass filled with water, add 2 tablespoons of sugar and keep stirring until the sugar dissolves. In a glass filled with water. How many tablespoons? Only 2 tablespoons sugar we are adding. Gradually now increase the amount of sugar into the same water. So more time it will take. It will take more time to dissolve it. And and again if we keep on adding the sugar into the water, it will take more time to dissolve into the water until unless all the intermolecular spaces present between the water molecules are occupied by the sugar particles. Then the sugar, what will it do? The remaining sugar will deposit at the bottom of the glass, and thus at that level only the volume of it increases. Explanation. The rate at which the sugar crystal dissolved in water is called the rate of diffusion. This rate was higher when the amount of sugar dissolved was less. As the amount of the density of sugar is now the density, the amount of density, the amount of sugar as we are increasing, the capacity of the water to dissolve into the the sugar is decreasing. So density of the sugar in the liquid increases, the time taken for the sugar to dissolve also increases. That is, the rate of diffusion decreases. Hence, the rate of diffusion and the density of liquid are inversely proportional to each other. So, as much as less we will add the sugar into the water, that much faster it will just dissolve into the water, means less, and it will dissolve the sugar. Now if we add more amount of sugar, now we are increasing the level of the sugar, and the time is and the dissolving time is increasing. So that's why by this we can conclude that the density and diffusion are inversely proportional to each other. If one increases, the another decreases, and the vice versa. How is melting point? This one is not there. Okay. Show by an experiment that by increasing the temperature, the substances can be changed into liquid and then into vapors. Experiment. Here is the diagrammatic representation. Okay. Take a few ice cubes in a beaker. In this way, I will tell you like this only. Okay. See, if we take here ice, then it and we just boil them, or we increase the temperature. What it will do? It will just the fusion takes place, and it will just form into a liquid. And after liquid, and again if we increase the temperature, it will evaporates into a gaseous form, and it evaporates. And if the same thing happens with when solid changes, let's say here we are taking a solid as naphthalene balls, and it is directly changing into a gaseous form, but the liquid state is absent. So this process we call as sublimation. And whereas from liquid to solid, that the process we call as solidification, and from gas to liquid we call that process as condensation. So here are the definitions of these. Fusion. What is fusion? The transition. See here, fusion. The transition of substances from its solid state to its liquid state, from solid to liquid state, is known as fusion. Vaporization. Here is the vaporization. Liquid to gas. The transition of liquid into its gaseous state is known as vaporization. Condensation. Condensation is the reverse. Gas to liquid. Okay. Like when we rinse, when the water vapors evaporates in the summer from ocean and seas, the condensation process takes place, and it will just condense into the clouds, and it forms a liquid, and the rains. Okay, that process takes place in when rain comes. Okay. Condensation. The conversion of gas into its liquid state when the temperature is lowered is known as condensation. So when the temperature is high, all the water evaporates, and it will goes into the atmosphere, and atmosphere where the temperature is cool, it will condensation takes place, and it forms into a liquid, and raining starts. Solidification. The transition of substances from its liquid to its solid state is known as solidification. Sublimation. The direct vaporization of solid into its liquid state is known as sublimation. What are the activities made by, okay, these activities are also not there. Let's skip this. How will you determine the melting point of ice experimentally with the help of a neat and label diagram? What do we have to determine? Melting point of ice. Take around 10 to 15 ice cubes in a glass beaker and arrange it on a tripod stand with the burner below it. Suspend a thermometer in the beaker in such a way that the bulb is in contact with the ice cubes. The clamp stand could be used to hold the thermometer and shown in the diagram. See here. This is the thermometer. This is a stand, clamp stand. We are just have tied here a thermometer into the ice cubes, and below that a burner is kept. This is we call it as a stand, that is a tripod stand on which a beaker can be kept, which has ice cubes, and thermometer. With the increase in the in thermometer we have a mercury. By we can see as the temperature increases, the mercury level comes up. So at what point it comes, we will just note down that, and by that we can say that at certain amount of temperature the ice started melting. Okay, now in written form you have to write like this. Okay, this one over. Switch on the flame on the burner and keep checking the reading on the thermometer. Record the initial temperature when the ice has just started to melt. Constantly keep stirring the melting ice cubes and record the temperature when the ice has completely melted into liquid water. So, at what point it started melting? Initial point, and you should see at what point all the ice cubes has changed into a water at that point. So, by seeing that we can find out the melting point of a ice. The melting point of a ice is the temperature at which ice gets converted from its solid state to its liquid state. For this, the solid ice needs energy to break the force of attraction between the ice particles so that the particles can be separated and the intermolecular spaces between them can increase. This energy is provided in the form of heat and is known as a latent heat of fusion. In the experiment demonstrated above, the heat from the burner is used to melt the ice. The thermometer helps to note the temperature at which the ice melts after the initial state. Hence the melting point of ice is 0 degrees centigrade or 273.15 Kelvin. In centigrade we write as like this, and in Kelvin we write as 273.15 Kelvin. Okay. How will you determine the boiling point? That is the melting point. Now the water has to be boiled to evaporate. The water experiment, draw an equilibrium diagram. So what we have to do, same experiment but increase in temperature where the water gets evaporated. So let's see this also. Take the 100 ml of water in a glass beaker arranged in a tripod stand with a burner below it. Suspend a thermometer in the beaker in such a way that the bulb is in the contact with the water. A clamp stand could be used to hold the thermometer and as shown in the diagram. Switch on the flame of a burner and keep checking the readings on the thermometer. Record the initial temperature when the temperature is just beginning to heat up. Keep monitoring the temperature change in the thermometer while the water is heating up further. After a while, notice the vapor coming out of the boiling water. Record the temperature till half of the water has evaporated. Notice the temperature in the thermometer will not rise above 100 degrees centigrade. So, we can conclude that 100 degrees centigrade is the evaporating point of the water or the boiling point of water. So here we have to write plus 100, that is 0 degree. So in Kelvin 273, here we have to add plus 100, it becomes 373.15 K. This is the boiling point of water.